Hello!
Hi, this is Rose and this is my final exam for the subject Advanced Mathematics. Today I will be solving 3 problems from the following topics.
Fourier Series expansion, matrices, and determinants.
But before that,
Fourier Series expansion. Find the expansion of the given Fourier series. A sub 0 which is equals to 1 over p integral of f of t dt from t sub 0 to t sub 0 plus 2p. Substitute the values of p and t, so we will have the integral of f of t dt from 0 to 0 plus 2. And then split into two integrals where f of t from 0 to 1 is 0 and f of t from 1 to 2 is t minus 1. We now have the integral of 0 dt from 0 to 1 plus the integral of t minus 1 dt from 1 to 2. We can then cancel the first term and then integrate the second term, which will give us t squared over 2 minus t. We substitute the values of t and we will get 1/2 for a sub 0. Next, we compute for a sub n, which is equals to 1 over p integral of f of t cosine n pi t over p dt from t sub 0 to t sub 0 plus 2p. We will again substitute the values of p and t. We will have the integral of f of t cosine n pi t dt from 0 to 0 plus 2. And we will have two integrals after substituting the value of f of t, giving us the integral of 0 times cosine n pi t dt from 0 to 1 plus the integral of t minus 1 times cosine n pi t dt from 1 to 2. Cancel the first term and apply linearity in the second term. This will give us the integral of t cosine n pi t dt from 1 to 2 minus the integral of cosine n pi t dt from 1 to 2. After performing integration, we will get t sine n pi t over n pi plus cosine n pi t over n squared pi squared minus sine n pi t over n pi. Then, we can substitute the values of t. So, we will have 2 sine 2 n pi minus sine n pi all over n pi plus cosine 2 n pi minus cosine n pi all over n squared minus sine 2 n pi minus sine n pi all over n pi, and combine like terms to simplify the equation, eventually giving us sine 2n pi over n pi plus cosine 2n pi minus cosine n pi all over n squared pi squared. Let us try to find the values of sine 2n pi, cosine 2n pi, and cosine n pi for any value of n. At any value of n, sine 2n pi will be equal to 0. Cosine 2n pi is equal to 1, and cosine n pi is negative 1 for odd values of n and positive 1 for even values of n. So, the equation will go down to 1 minus cosine n pi all over n squared pi squared. We will only substitute the value of n if we want to find the specific nth term of the series. Next, we compute for b sub n, which is equals to 1 over p integral of f of t sine n pi t over p dt from t sub 0 to t sub 0 plus 2p. After substituting the values of p and t, we get the integral of f of t sine n pi t dt from 0 to 0 plus 2. And similar to the first two, we will have two integrals again, which are the integral of 0 times sine n pi t dt from 0 to 1 plus the integral of t minus 1 times sine n pi t dt from 1 to 2, where the first one will be cancelled. We can apply linearity to the remaining integral to get the integral of t sine n pi t dt from 1 to 2 minus the integral of sine n pi t dt from 1 to 2. And then perform integration, which will give us negative t cosine n pi t over n pi plus sine n pi t over n squared pi squared plus cosine n pi t over n pi, and evaluate. So we'll have negative quantity of 2 cosine 2 n pi minus cosine n pi all over n pi plus sine 2 n pi minus sine n pi all over n squared plus cosine 2 n pi minus cosine n pi all over n pi. And eventually, we can combine like terms, giving us negative cosine 2 n pi over n pi plus Sine 2n pi minus sine 2n pi all over n squared pi squared. Previously, we found that sine 2n pi and sine n pi are equal to 0, and cosine 2n pi is equal to 1. So, our equation will be down to negative 1 over n pi. Now that we have the values of a sub 0, a sub n, and b sub n, we can now find the equation for f of t, which is equal to a sub 0 over 2 plus summation of a sub n times cosine n pi t over p plus summation of b sub n times sine n pi t over p. By substituting the acquired values, our answer will be 1/4 plus summation of quantity 1 minus cosine n pi over n squared pi squared cosine n pi t plus summation of negative 1 over n pi times sine n pi t. Matrices. Using the two given matrices, find the transpose of A plus inverse of A times B minus the transpose of B plus the inverse of B times A. First, let us find the transpose of matrices A and B. To find the transpose of a matrix, we just have to turn the rows into columns. This is the transpose of matrix A, and this is the transpose of matrix B, which as you can see is just the same as matrix B itself. Let's move on to the inverse of A and B. First, we should know that a matrix multiplied by its inverse is equals an identity matrix, which is similar to how a fraction multiplied by its reciprocal is equal to 1. So we can say that matrix A times the inverse of matrix A is equals to an identity matrix. Using that, we can form this, wherein we can use the letters A, B, C, and D as placeholders for the values in the inverse matrix. Then we can multiply the two matrices by multiplying the values of the first row from the first matrix and the values of the first column from the second matrix. Doing so will give us 3A plus C. And then we move on to second row and first row of matrix A in inverse matrix respectively, giving us 2A plus C. Then to first row and second column, which gives us 3B plus D. And then second row and second column, so we'll have 2B plus D. And then we can equate that to the identity matrix. If two matrices are equated like so, their corresponding parts will be equal as well. Like 3A plus C will be equal to 1 and 2A plus C will be equal to 0. Solving them simultaneously will give us the answers of A and C, which are 1 and negative 2 respectively. Likewise, 3B plus D is equals to 0 and 2B plus D will be equal to 1. Solving them again will give us the values of B and D, which are equal to negative 1 and 3. By plugging those values in, we get the inverse of matrix A. Next, we compute for the inverse of matrix B. We'll be following the procedure earlier. On our left side, we will have 2A plus C, A minus 2C, 2B plus D, and B minus 2D, which will be equated to the identity matrix. We know that 2A plus C is equal to 1, and A minus 2C is equal to 0. Computing for the values of A and C will give us A equals 2 over 5 and C equals 1 over 5. Likewise, we know that 2B plus D equals 0 and B minus 2D equals 1. Solving these two new equations simultaneously, we will get the value of B and D, which are 1 over 5 and negative 2 over 5 respectively. Plug those in and we get the inverse matrix of B. Next, we add the transpose and inverse. Let us first add the transpose and inverse of matrix A. This is the transpose of matrix A, and this is the inverse of matrix A. We will write them together like so. And to add two matrices, we will just have to add the corresponding parts, like 3 plus 1 equals 4, 2 minus 1 equals 1, 1 minus 2 equals negative 1, and 1 plus 3 equals 4. That is the sum of the transpose and inverse of matrix A. Next, we will add the transpose and inverse of matrix B. This is the transpose of matrix B, and this is the inverse of matrix B. Let us add the two together. 2 plus 2 over 5 equals 12 over 5. 1 plus 1 over 5 equals 6 over 5. 1 plus 1 over 5 equals 6 over 5. And negative 2 minus 2 over 5 equals negative 12 over 5. And that is the sum of the transpose and inverse of matrix B. Next step is multiplication. Let us multiply the sum of the transpose and inverse of A to matrix B. This is the sum, and this is matrix B. Write the multiplication like so. We learned multiplication of matrices while getting the inverse of the matrices. So now we have 8 plus 1, 4 minus 2, negative 2 plus 4, and negative 1 minus 8. By simplifying that, we get the matrix product of the sum of the transpose and inverse of A and matrix B. Next, let us get the product of the sum of the transpose and inverse of matrix B multiplied by matrix A. This is the sum, and this is matrix A. So, we will have this, and by multiplying these two matrices, we will have 36 over 5 plus 12 over 5, 12 over 5 plus 6 over 5, 18 over 5 minus 24 over 5, and 6 over 5 minus 12 over 5. That will be our product matrix. Next is to find the differences between those two products, which will also be our final answer for this problem. Subtracting matrices is the same as adding matrices. We only just have to subtract the corresponding parts of each matrix. By doing that, we have negative 3 over 5, negative 8 over 5, 16 over 5, and lastly, negative 39 over 5. And that is our final answer for this problem. Determinants. For our final problem, let us find the determinant of the matrix that we got from the previous problem. To find the determinant of a 2 by 2 matrix, we have to multiply these two and then subtract to that product the product of these two. By doing that, we'll have negative 3 times negative 39 over 25 minus 16 times negative 8 over 25. We will simplify them, so we will get 117 over 25 plus 128 over 25. Adding those two together gives us 49 over 5, which will be our final answer for this last problem. Now, we can have the recap of answers. For number 1, we have f of t is equals to 1 over 4 plus summation of 1 minus cosine n pi over n squared pi squared times cosine n pi t plus summation of negative 1 over n pi sine n pi t. For number 2, this is our answer. And for number 3, the determinant is 49 over 5.
That will be all for today. Again, I'm Rose, and thanks for watching.